Okay, so in this video, I'm going to just talk about how to do section 5.3, number 38 on the homework. So I'm going to go through this problem. This one looks a little nasty, right? We're trying to find the partial fraction decomposition of this rational function here. And so our first step in dealing with this is factor the denominator. I'm just going to abbreviate it denom, if that's okay. So we want to factor the denominator. And the denominator is this x cubed minus x squared plus 2x minus 2, right? That's the bottom part of our fraction, the denominator, okay? So what I'm going to do here, I have a cubic that I want to factor. It's cubic because it has a third power on it, okay? So we did a lot of factoring earlier in the year, and that was kind of a struggle for us. You could do a kind of like rational roots thing. That's the P over Q thing, where you look for what rational roots would this have, and you plug them in, right, and check them and see which ones work, and then you do synthetic division to kind of factor it. This one, there is a slightly easier way that you could factor this, and it's because it's a cubic. There's like 4 terms here, so I'm going to try factoring by grouping first, okay? So I'm going to factor this part and see if I can kind of use factoring by grouping, okay? So this part, what can I factor out of these two? Well, there's an x squared on both of them, so like an x squared will go into each one. So when I factor that out, I'm left with an x here and a minus 1 there, okay? Now for this other one, what can I factor out of these two? Well, there's a 2 in both of them, so we can factor out a 2. And we're left with just an x minus 1 on the inside. We're doing the opposite of distributing, right? We're factoring, okay? Now what you'll notice here is that these two are the same, okay? X minus 1 and x minus 1. So factoring by grouping works here, okay? We can use it. If these aren't the same, you can't use it, okay? And you've got to do your P over Q thing. I don't think there's any on the homework where you can't. I think this is the most complicated one that you have to deal with anyway, so you should be okay there. But this is x minus 1, this is x minus 1. So in total, I've got x squared plus 2 and x minus 1. I just combine those two together, and then this one is left by itself, okay? So this is our factored denominator, okay? We factored it. I should check and make sure, can I factor it anymore, okay? Well, this guy doesn't factor anymore. But what about this x squared plus 2? Does that factor? Well, if it did, I would be needing numbers that multiply to 2, positive 2, and that add to 0, okay? Well, 2 and 1 are the only things that multiply to 2, but when you add those, you're not going to get 0. I guess you could do negative 1 and negative 2, but still you're not going to get 0. So this doesn't factor. So this is as factored as it can get, okay? I mean, it does factor if you use complex numbers, but we don't really want to do that, okay? So we're just going to leave it like this, x squared plus 2, okay? So we factored the denominator, and that maybe was probably what was throwing us off a little bit, okay? So now that we have the denominator factored, our second step here, step 2, is what does our final answer, what should it look like, right? We want to figure out what our final answer look like. So let's go back up. What was on top of our fraction? 3x squared minus 2x plus 8. 3x squared minus 2x plus 8. Okay. And then we factored our denominator, right? We just have x squared plus 2 and x minus 1 as our factors in the denominator. So this is what we're dealing with. We're trying to find the partial fraction decomposition of this rational function. Okay, so what am I going to do here? I look at each factor in my denominator. Okay, so I'm going to start with this one. This is an x squared plus 2. Okay, and it doesn't factor any more than that, right? This is a quadratic factor that is irreducible. It can't factor. So when I do my thing over here, I'm not just going to have a number on top. I'm going to have an ax plus b, a linear thing, because this is quadratic. Okay, so x squared plus 2 is on the bottom, and then a linear function is on top. Okay? Plus, well, our other factor is x minus 1. That's a linear factor, and it's not repeated, so we just throw a letter on top. Okay? So this is what this would look like. That's our final answer. Okay? So, now that we have that, step 3, we want to find A, B, and C, right? We want to find out what A, B, and C are. So what I'm going to do is I'm going to take this and times it by the denominator. Okay, so I'll times it by x squared plus 2 and times x minus 1, just by the denominator of this thing. What happens when we do that? We should get rid of all the fractions here. So this will cancel out, and I'll just get 3x squared minus 2x plus 8. This equals ax plus b. We'll still have this ax plus b, but I should look at these two are timesing by this one. There's an x squared plus 2 in the bottom times an x squared plus 2 in the top. That's going to cancel out. We're just left with x minus 1. Okay? And then our last thing is plus c. The x minus 1 should cancel out, and I just have x squared plus 2. Okay? So there's an example there of we're just distributing our denominator through the whole thing, timesing it by the whole thing to get rid of the fractions. Okay? Okay, we're getting there. So, now let's look at this equation here. So if you remember, to find A, B, and C the way I normally do it, the book does something else, but the way I normally do it is I plug in numbers for x, okay? And then I solve for the things that I want to figure out, okay? So first things first, I should look in here and figure out where is this going to be 0? Where will all of this part cancel out of the equation? Well, it's when x is positive 1, okay? So I'm going to set x to be equal to positive 1, because that will make this 0, and then it will get rid of a and b from the equation, and I will just have c that I can find, okay? So I replace x with 1. We get 3 minus 2 plus 8, just plugging in 1 for x. When I plug in 1 for x here, this all cancels. It's all 0. And we just get c times 1 plus 2, right? 1 squared plus 2 squared, or plus 2. Okay, so now we have 3 minus 2 is 1 plus 8. And then this is 3c. So we get 9 is equal to 3c. And we just divide by 3 on both sides. So we get 3. Okay, 1 down. 2 to go. So the next thing you want to look at here is we're going to set x equal to some other number so that I can find a and b. Okay? Well, this guy, this x squared plus 2, this isn't equal to 0 for any real numbers, right? So we can't really make this go to 0. But what you can do is if you look in here, another good number to use when you have a linear thing in here is if you plug in 0 for x here, right? That will make the a go away in the equation, okay? So I'm going to set x equal to 0, and then I won't have as many variables in my equation. Okay, I'm going to set x equal to 0. When I do that, these guys cancel out, and I just get 8 is equal to, well, 0 times a is 0, plus b is just b, times 0 minus 1, and then plus 0 plus 2 is 2, 2c. So we get 8 equals negative b plus 2c. Okay? Now why is this really good? Because this now, I have 2 variables in it, right? Instead of 3. I already know what c is, right? So I can plug in c into this equation and I'll only have b left over. So I'm just going to put c in, so I get 2 times 3. So this is 6, 8 equals negative b plus 6. Then I'm just going to subtract the 6 over. I get 2 is negative b. In other words, b has got to be negative 2. Okay? So, I found c, I found b. Now I just need to find a. Okay? And to find a, I really can just plug in any other number as long as it's not these two, okay? Because those ones make the a go away. So I don't know what we could do. Maybe I've already done 0 and 1. Let's do maybe 2. So I'm going to set x equal to 2, okay? Let me scroll up a little bit and we'll see our equation again. When I set x equals 2 in this equation, I get 2 squared is 4, times 3 is 12. 2 times 2 is 4, so minus 4, plus 8 is equal to 2 times a, so 2a, plus b, And then 2 minus 1 is just 1. So 1 times this just stay the same. And c times x squared plus 2. So plus c times x squared. So x is 2, so that's 4. Plus 2 is 6. Okay? I'm going to scroll a little bit further down. So we've got some more space. So I just plugged in 2 for x. And this is what I get here. Okay? So 12 minus 4, that's going to be 8. Plus 8 is 16, is equal to 2a plus b times 1 plus 6c. Okay? So, why is this good? I have an equation with all 3 variables now, but I know b and I know c already, right? So I know c is 3, and I know b is -2, so I'm going to plug those in, okay? I'm going to plug in c is 3, so we still got 2a, b was -2, so we'll plug that in, and c was 3, okay? So now I just simplify things. I get 16 is 2a. This would be plus -2 plus 18. So we get 2a, and then -2 plus 18 is plus 16. 16. Now we just subtract the 16 from both sides. I get 2a is 0. So then a should be 0. Okay. So it turns out we really didn't need that x in this equation, okay? But for some of them you do, so you have to throw it on there. Okay? So we found A, we found B, we found C, so we're done. We just need to write out our final answer. So scroll back up. What did our answer look like? It was like this, right? ax plus b over x squared plus 2. So my final answer here, a was 0, so I'd have 0x plus b is -2, so just -2 divided by x squared plus 2. And then for our other one, c was 3, and it was divided by x minus 1. Okay. So that would be our answer there. So hopefully that helps with that question. I know that one's a little bit trickier than some of the other ones we were doing. Okay. Good luck. I'll see you in the next video.